I have opened the age and memory dataset from statsci.org, and I'm going to take a look at doing just a one-way analysis of variance with multiple comparisons to look at the difference in the number of words recalled over the different memory tasks. But I'm not going to look at the age group. So you can see in the plot here that you could do a two-way Anova including the age group. I'm just going to look at a simple one with just the process that they were using. So we're looking for a difference in the mean number of words recalled. We have more than two groups, so we can use analysis of variance for this. Excuse me. The first thing we might want to do is do a few graphs and check some of the assumptions of analysis of variance. So in the chart builder, could look first at the box plot. The scale or dependent variable will go on the y-axis, and the groups, in this case the level of processing, which is the memory task they were using, goes on the x-axis. And things that we would be looking at here would be for similar levels of variation, which is, you can do a formal test for that, and you could also look at some histograms for that, but you can see it in the box plots too. And we would be interested in any outliers. So there are a couple of outliers here. I know that there's only a sample size of 20 in each group, which is not huge, so I think possibly if you had bigger sample sizes, these may not be outliers. In any case, what may happen is that these may obscure any differences in this particular mean from some of the others. So possibly a bigger sample would help that. I'm not too worried about them. I don't think they will hide any overall results because they're not too extreme. It does appear from this plot that there's a bit more variation in some of these tasks. So this box plot is way more spread out than, say, this one. And if we do a plot with the means and the confidence intervals, that will show up there as well. So if I drag in the error bar chart, and that gives us the mean, and you can tick this box if it's not already ticked for display the confidence intervals. And we can see that the confidence intervals are much tighter for the counting and rhyming than they are for the other three. These are a bit more spread out, and that's due to more variation in the data. Now we would also be interested in assessing whether these are approximately normally distributed. You can sort of tell that from the box plots depending on how skewed they are, but it's probably easier to look at a histogram. I find that the Legacy Dialogues has a better histogram for looking at different groups. So we've got words recalled with level of processing, and we're going to put the normal curves on top. So the counting and is looking pretty normal. The rhyming, well, you've got a bit of a bump there. Now these three ones are really quite spread out, and so possibly they're a little bit too flat to be completely normal, but this may also be due to the small sample size of having only 20 in each group. Anova is a fairly robust test, and I'm going to say it'll probably still be able to detect a difference here, even though there are a couple of problems with the data. It's not completely perfect. So the null hypothesis that we're testing with analysis of variance is that all the means are the same. Now clearly from the graph it does not look like all the means are the same, and so we'd probably expect to get a significant result here. To run the test, we go to Analyze, Compare Means, and the one-way Anova. We've got words recalled as the dependent variable, and our factor or our groups are the level of processing. If we're interested in specifically which groups are different from the others, we would want to run the post hoc tests as well. You don't need to run all of them, you just need to pick one. I've just been using Tukey's. You could pick a different one based on whatever you're doing. And we see that the Anova is in the first box, and that's pretty small. So the null hypothesis is that all the groups are the same. We've got a very small p-value, so we've got very strong evidence against the null hypothesis, suggesting that at least one of the means is different from the others. And the multiple comparisons will give us the details of those differences, so we can comment on those. Now there's two lots of output for the Tukey's version. I quite like this bottom box because it puts them into groups. So this is telling us that the counting and the rhyming were not statistically different from each other, with mean number of words recalled between 6 and 7, and that the adjective, imagery and intentional tasks were not statistically different from each other between 12 and 15. It does look like the imagery and the intentional are closer together than the adjective, and remember that this is the group that had the outliers in it. So if the mean truly is lower for the adjective task, we weren't able to pick that up in this particular data set, perhaps due to the smaller sample sizes and perhaps because of the outliers. So we have no evidence for a difference here for the adjective task. If we wanted to look more into that, we'd probably have to run another experiment. If we want to look at every possible pair of tasks, which is summarised here, we can go through each of the separate tests in this table. So this is testing, is adjective the same as counting? We've got a very small p-value, so we've got strong evidence that adjective and counting are different. Then it's testing adjective and imagery. We've got a higher p-value, no evidence that those two are different. Adjective with intentional, no evidence, and adjective with rhyming, again, very strong evidence that they're different. So this table is going through every possible pair of means, and then this table here will summarise it. And usually this will match up quite nicely with your means and confidence intervals. Where you get a complete separation of the confidence intervals, you'll get a significant result. Where there's a little bit of overlap, so if you can see where adjective overlaps with imagery, it can be a little bit difficult to tell just from visualizing it if it's statistically significant. You usually have to run the test. It's possible that they can overlap a little bit and you still get a p-value less than 0.05, and I will let you Google that if you want to read the maths behind it. So if unsure, run the test. Where you do get a nice picture like this, it's always good to display the results with the means and the confidence intervals.